In questions 21 and 22, what we're looking for is trying to get the bases to be the same. And you will have directions like this on your test, and we'll specify on the ones where we're trying to get the same base. So on 21, you have a 9 and a 27, and you're looking for what number raised to a power can get you a 9 and a 27. So obviously 9 goes into 27, but 27 is not a power of 9. 9 times 9 is 81, which is not a power of 27. However, 3 squared gets you 9, and 3 cubed gets you 27. 3 is the base, which both of those can be generated from. So 9 is 3 squared, but that would then still need to be raised to the power of 2y minus 1, and a power to a power you multiply. And then this equals 27, which is 3 to the third, which then has to still get multiplied by y. So now if the bases are the same, you can eliminate the bases, which means the powers have to be equal. So this is not 2, sorry, this is 4. This is 4y. 4y minus 2 when you distribute equals 3y. And bring the y to one side, you get y equals 2 as your answer. Okay. On 22, here, 5 and 125. This one probably is a little easier for you. They're both powers of 5. So this is 5 to the 4x minus 2 power equals 125 is 5 to the third power, which then still has to get multiplied by x plus 1. So then here, since the bases are the same, the bases are irrelevant. The powers have to be equal. So 4x minus 2 has to equal 3x plus 3. So bring the x over, bring the 2 over. X has to equal 5. Okay? So those are the problems where you're trying to get the bases to be the same. Okay? Then let's start looking at the bottom here. One other type of problem is where it'll look like an exponential, but it's really just a base to a power here, where the power is a numeric value, so we're just going to need to bring the power to the other side. So this is x equals 27. This is 3/4, so this comes over as the 4/3 power. And we know the bottom number, again, is the root, and the top number is just the power. So this is x cubed root of 27 is 3 to the 4th power, so x equals 81. Okay. 24, same thing, except here we have this extra 5 here. We're subtracting these. So I'm going to bring the 5 over. So this is negative x to the 1/3 equals, subtract off the 5, you get negative 1. Make both sides positive because you're dividing by negative 1. And then this is going to be x equals 1 to the 3rd power. So x equals 1. Okay. And the next one, here we have a single log. So this is what we were doing on the front side here with the BAP. If you have a log with a base and answer power, we can actually switch forms. We can switch that into base to the power equals an answer. So if we do that here, our base is assumed to be 10 on a log. So we're going to switch forms. This is 10 to the power of 1 equals your answer, which is 3x. 10 to the first is obviously just 10. So we're going to take 10 divided by 3. That's equal to x. So then x is approximately, I think the directions here say go to the nearest hundredth. So that'll be 2 spots on this one. So that would be 0.33. Okay. Then